So welcome back to Engineering Economy. We are starting a new chapter in our book. This is chapter 11, in which we will consider the uncertainty. We will learn how to deal with uncertainty, and we will talk about the break-even analysis and sensitivity analysis. Actually, in engineering economy, we are trying to make decisions for future. And when we are talking about future, it's full of uncertainties. You cannot know the future for certainty. There are different sources of uncertainties. We will talk about these. And it's important to know how to deal with these uncertainties, how to do this break-even and sensitivity analysis so that you can make the optimal decision. Of course, it's very difficult, but for the given data, given information, you may come up with different analysis and select the best one depending on the information that you get. And in this chapter, we will learn these important concepts to deal with uncertainties. So let's get started. So our learning objectives in this chapter is to illustrate how we deal with uncertainty and risks, and to illustrate these break-even and sensitivity methods for investigating these situations resulting from these uncertainties, investigating the variability in the outcomes of engineering projects. So if you know in the future time for sure, if you know it with confidence, if you make your decision with a confidence, then we call this a decision with certainty. Okay, you know it for certain, you know the future outcomes for certain, and your decision is made under this assumption of certainty. But since we are considering future factors, and in almost all engineering projects, there is no such thing as certainty, full certainty, and we need to consider the uncertainty in our analysis. So the risk and uncertainty are considered to establish the bounds of error, okay, in the estimate of alternatives. So in order to make your decision now, we need to estimate the future values, the revenues, the costs, the demand, many things. And these estimates gives us some errors. And as a result of these errors, estimation errors, we may end up with wrong decisions. And this is the wrong decisions, or these errors are actually because of these risks and uncertainties associated with the future occurrences, future outcomes. So we are talking about risk and uncertainty, but what are they? Actually, risk and uncertainty are similar. We will talk a little bit on this. So they both represent the problem of not knowing what future conditions will be. For example, the price of oil. So can you know the price of oil 2 months from now, 3 months from now, 1 year from now? Of course, it's unknown. Okay? You may have some estimates. You can look at the past figures. You can try to figure out what's going on in the current global economics. And depending on these, you can say that, okay, 2 months later, the price of oil will increase to $60 per barrel, and etc. But the thing is, if during this time if there is a pandemic spreads out, if there is a war between two countries, and etc., then the price of oil will be too different. It will be too much or too less. Okay? So because of these unknown factors with the future conditions, we don't know the future for sure, and it means that we have risk and uncertainty. So they show or they present the problem of not knowing what future conditions will be. But if we don't know what future conditions will be, does it mean that we will not make a decision? No, we still need to make a decision now. If you want to buy a car, can you say that, okay, since I don't know what will happen to the gasoline prices in 1 year from now, I will not buy the car? No, you still need to buy that car. You still need to make that decision. Okay? But the decision that we make under such unknown conditions, such uncertainties, is called decision under uncertainty. Okay? As we said, this risk and uncertainty, sometimes we use them interchangeably to represent the same thing, but actually there is a difference between them we will talk about. So when we are dealing with uncertainty, if we determine in what degree the change in the estimates, so when we are saying estimates of the revenues, costs, demands, so we need to estimate their values. But if these estimated values are changed from the values that I estimated, so up to what degree of change our decision will be affected, or how it will be affected. When we analyze this, when we determine this, it is called sensitivity analysis. Okay? The sensitivity analysis actually measures how our decisions will be affected when the estimated values are changed, are different than our estimates. In some cases, a small change in a value, for example, you estimated the revenues to be $10,000 per year, but instead it is not $10,000, but it is $9,500, 500 less each year. A small change, but such a small change may reverse our decision. If it was $10,000, we accept the project, but when it is 9,500, we reject the project. Okay, our decision is reversed. So if this is the case, if a small change reverses our decision, then we say that this decision is highly sensitive to that factor, highly sensitive to annual revenues. Okay, we can say this. But if, for example, our estimated annual revenues is $10,000, but even if it's reduced to $6,000, a lot of difference, but still we accept the project, then we can say that the decision is not too sensitive to the annual revenues. Okay, it's not highly sensitive. We said that risk and uncertainty are used interchangeably. Risk offers estimates of possible outcomes. So we can say that risk is a measurable uncertainty. It's measurable. So we can say that there is a 90% probability that this will happen. So that 90% is a measure to estimate the risk in the project. We can measure its value. Okay? But in uncertainty does not provide estimates for possible outcomes. It is the unmeasurable risk. You don't know if it is 90% to have a chance of occurrence and etc. Okay, so the difference between risk and uncertainty is this: risk is measurable uncertainty, and uncertainty is unmeasurable risk, but they are similar because they show us, they indicate the problem of not knowing the future. What are the major sources of uncertainty? We can talk about 4 major sources of uncertainty. First is the possible inaccuracy of the cash flow estimates used in the study. So in order to have an engineering economic analysis, you need to know the future cash flow, the revenues, costs, and etc. And you may have inaccuracy in these estimates, and because of this inaccuracy, it provides us an uncertainty. Okay? The second source of uncertainty may arise from the type of business in relation to the future health of the economy. I gave you this example of gasoline prices. So the gasoline prices are affected by the global economical situations, political situations, many factors. And if your business have anything to do with the gasoline prices, and if you need to estimate their prices for future years, because of these uncertainties in the economy, your business will be affected. Or for example, if you have a business in tourism sector, and for the next year you need to make some decisions, maybe to increase your capacity, your hotel's capacity, and etc. You need to estimate for future, but if during this time there is a pandemic, so that every country closes their borders and no tourists are allowed, and what will happen to your business? Okay, so such an uncertainty arises because of the future health of the economy. It can be sourced because of the physical plant and equipment involved in the project. In some cases, you need to construct a building, you need to buy a machine, and etc. And usually these equipments, machines have their useful lives and market values. Sometimes you know these useful lives and market values for more certainty, but in some cases you don't know these values because they are in the future and they are sources of uncertainty. And sometimes the equipments that you are using in your business may have only a little resale values or no resale values. And actually in this case, maybe you can be more sure, you can be more certain. But in this case, you need to estimate their useful lives and market values, and they are sources of uncertainty. And also the length of the study period is another source of uncertainty, because when the study period is longer, it is difficult to estimate. The level of uncertainty will be higher. Okay? If you are estimating, for example, the weather forecast, think about the weather forecast. If you are forecasting 1 hour from now, it's more accurate. If you are forecasting 12 hours from now, it is less accurate. If you are forecasting the weather for tomorrow, the next week, okay, as the time increases, the level of uncertainty increases. Okay, so this is another source of uncertainty. Okay, we said that we do sensitivity analysis to understand how each factor that appears in my analysis affects my decision. Okay, so we measure the degree to which the measure of merit, it can be present worth, annual worth, future worth, rate of return, and etc. How these measures will change as a result of change in the study factors. Okay, the sensitivity analysis does this. What are several techniques used for sensitivity analysis? the break-even analysis. Okay, this is one method to do sensitivity analysis. And actually, if only one factor is involved, is more dominant in your analysis, or the most uncertainty arises from this single factor, then you can use break-even analysis. If there are multiple factors affecting or may affect your decision and may have uncertainties, then you can use sensitivity analysis. We will talk about these spider plots. Or if these factors are not independent of each other, but they are dependent to each other, then we can consider their combinations and consider these combination factors. So in this course, we will see the break-even analysis and sensitivity analysis. So break-even analysis, we said that when there is a single factor, for example, this single factor can be the useful life, the study period, the interest rate. Okay, there is only one factor. It can be the capacity utilization. This factor determines the selection of an alternative or acceptability of an engineering project. This is the dominant factor, or the factor which has the only uncertainty. Then we can use break-even analysis. Okay. So, for example, if we are trying to select between two engineering project alternative, and this selection depends on a single factor, then the break-even analysis can be used as the analysis to determine which of these projects to be selected. When we find a break-even point, okay, the break-even point, depending on the estimated value of that factor, okay, so for example, the capacity utilization, we found the break-even point for capacity utilization to be 90%. And we estimate the capacity utilization to be around 80%, lower than the break-even point. It indicates that you are going to select one of the alternatives. But if it is larger than 90%, then you will select the other alternative. So this 90%, the break-even point, is the point of equivalence, point of changing the decision. If it is lower, one alternative is better. If it is higher, the other alternative is better. So what is the general procedure in doing break-even analysis? First, we write an expression of the equivalent word. When I say equivalent word, you can understand present word, future word, annual word. Write an expression for the equivalent word, which depends on the common factor. This common factor, as I told you, can be the capacity utilization, or the interest rate, or the revenue, whatever it is. Okay, so your equivalent word will depend on this common factor. Then we equate these equivalent words of the two alternatives to each other and solve for the common factor. This value of the common factor that makes two equivalent words equal to each other is called the break-even point, BEP. Then you will estimate whether the actual level of this factor is higher or lower than the break-even point. And depending on that estimate, in comparison to break-even point, we select the most appropriate alternative. Okay, this is the general procedure of a break-even analysis. So if we show the procedure in mathematical terms, we can say, let's assume that there is a factor which is y. Let this y be the interest rate. Then we are going to write for alternative A its equivalent word using this interest rate. So what do I mean? Let's assume that we have this project A. It has a cash flow of something like this. But the thing is, I don't know what the interest rate is. There's an uncertainty here, and I want to find the break-even point of this interest. So what do? I can find the present worth of this A, okay, using as a function of this A. Let's say that this is $10,000, 10,000 plus, then the earnings is, let's say 1,000, 1,000 times, then we say it's P given A, I, okay, look, it's I, and then let's say 6, and assume that this is the present worth. Now I have written this present worth as a function of this I. Okay, so this F1 of I means we are writing the equivalent worth as a factor of this factor. And for B, again, we write the equivalent worth of B with respect to this factor. And in order to find the break-even point, we set these two equivalent words equal to each other. So the present worth of A, I will set it equal to present worth of B, and I will try to find the value of this I, or you will try to find the value of Y. If you have only a single project alternative, not two alternatives, but a single project alternative, and you want to understand whether it's acceptable or not, again you would do the same thing. Write the equivalent worth of this single project with respect to the factor that you want to identify and make it equal to 0. Okay? And when you make it equal to 0, you will find the value of Z, so that this is the break-even point for that Z. If it is less than Z, you can say that accept the project, or and greater than reject the project, or vice versa. Okay, depending on this break-even point, you can make your analysis. Here, equivalent worth of A, this notation, it indicates the equivalent worth, which can be present, annual, or future worth of alternative A. Similarly, this is for alternative B, and here Y and Z, actually, they are the common factors of interest for us. I mean, which factor we are interested in. In this example, it is the interest rate. In another example, it can be the number of periods. In another example, it can be the annual revenues. Okay. So there are some common factors that are used in break-even analysis. What are these common factors? You may be interested in the annual revenues or expenses. You may be interested in the rate of return, or the market or salvage value. So you may want to write your present worth as a function of the salvage value. Okay, so you write everything, and then the salvage value, you don't know what it is, and you write P given F, for example 10% and 10. You write everything and make it equal to 0, for example, and find the S. So when I say these common factors, it means that in this alternative, you try to find the break-even point in terms of the salvage value. Here, you want to find the break-even point in terms of the equipment useful life, or the capacity utilization. Okay, these are common factors. Of course, there may be some others, but these are the most common factors. So let's solve this example from your book, and it will be it will help understanding. It's said that there is a homeowner who wants to invest in solar panels at the top of his house, at the roof of his house. He wants to install solar panels. And there are several information related to this. It's said that the cost of electricity is this much per kilowatt hours. When you install solar panels, the government subsidizes 70%. So what does subsidizing means? It means this. If you, for example, pay $100 to install these solar panels, the government says that I will give 70%, which is $70. I will give $70 for you. You will only pay for $30. Okay, so here we also have this subsidizing. If you are using electricity, for example, the government subsidizes some part of it. You are only paying a portion of it. The remaining part is paid by the government. Okay, so this is what subsidizing means. It's said that the square foot of panel can produce this much electricity, and the cost of installing these solar panels per square foot is this much. It's said that you have available space for this much. You are going to install a solar panel of 350 square feet. And the question is, what is the break-even point in years? In years. Okay, break-even point in years for the installation of solar panels. Assume the homeowner's interest rate is 6% per year. Okay, so we need to sketch this cash flow. We need to have some initial investment, and due to these installing solar panels, we will have some savings from electricity. And it's asked, okay, in how many years this initial investment will be covered by this annual savings? Okay, and what is this initial investment? The initial investment is this one, the installing cost, $93.91. But this is per 1 square foot, and I need to multiply it by 350 so that this is the total investment cost. But 70% of this cost will be paid by the government. So I'm going to pay only 30% of it. So it means that the initial investment cost for me is the 30% of this total cost. Okay, what about the annual savings? The annual savings will be due to the energy cost. Okay, since these panels will produce energy, I will not buy this energy from the electricity company. I will use the energy that I produced. And in total, what will be the amount of saving each year? So it's said that 1 square foot of panel saves this much energy, produces this much energy, but I'm going to install 350 square foot, and the cost of this is the total energy produced, and the cost of this energy was this. So instead of paying this amount to the electricity company, I will use it less from the company, use the energy produced by myself. And this will be the annual savings. And what we try to find is, we try to find the present worth of this cash flow, okay, which is this initial amount. Let's say this is the annual savings. Investment, this is negative, plus this annual P given A, the interest rate is 6%, and the number of periods is the question. And I will make it equal to 0 to find the n from this equation. Okay. So this is the solution actually. This is the total 30% of the total cost, and this is the annual savings, and this x is the number of periods. And when you solve this equation with respect to n, you will see you can use trial and error here. You say that the number of periods is between 21 to 22 years. And this is the graph. Okay, our initial investment was 10,000. And these are the annual savings. If you use this for 2 years, your savings is this much. 4 years, your saving is this much. How do we find it? Simply in this equation, if you write here 2, you find this value. If you write 4, you find this value. And you write all these values, you can do it easily in Excel. And the point where this savings crosses the investment is your break-even point, and it is between 21 and 22 years. And what does it mean? If, for example, the useful life of these solar panels is less than, let's say, 21 years, if it is 16 years, as you can see, investment is more than your savings. It means that you shouldn't select this project. If it is longer, then your savings are greater than your investment. But still, you can have a look at these differences. Okay, after 20 years, I recover my initial investment, and even in 28 years, my savings will be only this amount, this much. So I am going to make this investment for 28 years, and in 28 years I will only save $1,000. And at this point you can say, no need to do this, or yes, I will take this project. It will be your decision. But this graph helps you how to make this decision. Another example is this one. So you want to buy, let's say, a car. The gas, electric, or hybrid vehicles, you can have these cars, and they have some savings due to using the electricity. They have savings over gasoline. Okay, so assume that there is a hybrid vehicle with a price of this much, $31,500, and its consumption is, I mean, per gallon, you can travel 30 miles with this car. It said that there is a tax credit of $1,500. What does this tax credit means? Again, the government pays you this amount back when you buy this car, because you are saving from gasoline. The government subsidizes it, and actually you are paying 31,500 minus 1,500. Okay, then the total price that you are going to pay is this much, 30,000. There is another gasoline-only vehicle which is $28,000, and its energy consumption, it can travel 25 miles per gallon of gasoline. The interest rate is 3% per year, and the study period is 5 years. It says that find the break-even cost of gasoline if the vehicle will be driven 18,000 miles each year. Okay, so it means that there are two alternatives: hybrid, and gasoline. Okay, each one of them has their costs, and I need to find their break-even point with respect to the price of the gasoline. I don't know what will be the gasoline price, so I want to find the break-even point, and according to that break-even point, I will do some analysis. Okay, actually it's not difficult, it's easy. For this hybrid vehicle, again, you have initially $30,000, and each year you need to pay this gasoline price. So what will be the total gasoline amount? This 18,000 miles, I'm going to drive it in 1 year, 18,000 miles. Okay, and this gasoline vehicle can travel 30 miles per gallon. So if I divide it by 30, I will find the amount of gasoline that I am using to travel this 18,000 miles. And if I multiply it by the gasoline price, so let this, I denote it by X. Okay, so this will be the amount of cost that I am paying. So since this is cost, I will write it in this way. Similarly, for the second one, initially I am paying 28,000, and each year I am still traveling the same amount, but this time I am traveling 25 miles per gallon, and if the gasoline price is X, This is the amount that I am paying each year. And the study period is 5 years, and the interest rate is 3%. Now the only thing is find the equivalent word. It can be present word, annual word, and etc. of the first alternative and the second one, and make them equal to each other and find the value of x. And if you do this for hybrid, this is the calculation, and for gasoline only, this is the calculation. You will find this x to be $3.64 per gallon. And you can sketch the pictures. So this blue one is the gasoline only alternative. As you can see, up to this point, the gasoline only alternative has a less cost. But after this break-even point, the minimum cost is given by the hybrid alternative. Now the question is, what will be the gasoline price? What's your estimate for the gasoline price? Will it be less than this value or more than this value? If it is less than this value, you need to select gas-only alternative. If it is more than this value, if your estimates for future is more than this value, you can select the hybrid alternative. Okay, this is the idea of break-even point.